In this video, we're going to talk about completing the square to solve a quadratic equation. So completing the square is another way to solve a quadratic equation aside from the quadratic formula or factoring. It is a way to solve an equation that when you look at it and think not factorable, a way that you can alter the equation in order for you to solve and find the roots. So the objective of completing the square is to create what's called a perfect square trinomial to easily solve a quadratic equation. So what I mean by a perfect square, in sense of numbers, we would think of 4 as being a perfect square, because when I take the square root of 4, I get a plus or minus 2, so I get an even whole number. And it doesn't necessarily have to be even, so 9 is also considered a perfect square because when I take the square root of 9, I get plus or minus 3. So it just needs to be a nice, what we consider pretty whole number. So what that means for a quadratic is if I had a squared plus 2a plus 1. This expression here would factor down to a plus 1 times a plus 1. Which we could express as a plus 1 quantity squared. This makes a squared plus 2a plus 1 what's called a perfect square trinomial. And so the process of completing the square is to take an expression that's not a perfect square and get it to a perfect square form for us to factor down and solve. So let's look at an example of this technique. So I have the example a squared plus 2a minus 3 equals 0. So if we try to factor this down, we know that this does not factor down, or you could factor this down, but let's look at how we could complete the square. If you factored it, we would factor it down to the roots negative 3 and 1, but what we want to do is to get it where it's a perfect square. So I'm going to group my coefficients to begin with. Notice how I'm leaving gaps between, in parentheses, and after my constant here. So once I do this and I group my coefficients, or my variables, I'm going to take this b coefficient and I'm going to divide it by 2. Alright, so in this situation 2 divided by 2 is 1, and so I know that one of the factors of this perfect square trinomial that I'm going to create is 1. But then when I take the square of this product, or this quotient, which is 1 squared, which gives me 1, I know that this second quantity is what I'm going to add to my group to make my grouping a perfect square trinomial. So what that means is a squared plus 2a plus 1 will factor down to a plus 1 squared. Now, since I added a value inside this grouping, I need to add it to the other side of my equal sign, or what I can do is subtract it from this constant. And what this does is this balances out. We can't just add a number to change an equation without doing it to the other side in order to maintain balance. So then when I simplify here, negative 3 minus 1 gives me a negative 4. I get something where I have one variable and I can now solve algebraically. So in this situation I would add 4 to both sides, and then I would take the square root, which gets rid of this exponent here. So now I have a plus 1 is equal to a plus or minus 2. After I subtract 1 on both sides, I get a is equal to a negative 1 plus or minus 2, which in this situation comes out to a negative 3 and a positive 1. So the roots of this equation are negative 3 and 1. So let's look at another example of completing the square. And this time we're going to do it where the a coefficient, or my leading coefficient, is not 1. So it's important when we complete the square to make sure that our leading coefficient is 1. In this situation it's 4. So when I go to group my coefficients here, or I'm sorry, my variables, I would end up grouping the 4v squared plus 16v. I would notice that v squared's coefficient is 4, not 1. So what I end up needing to do is factor out that 4. So when I do that, I get v squared plus 4v, and by factor out I'm just dividing a 4 from each of these coefficients. And then I could go ahead with the process of completing the square. So taking 4, dividing it by 2, and then squaring that quotient to get 4. So I would add 4 here in my group in order to get a perfect square trinomial. So in the previous example, when I added 4 inside my group, I subtracted 4 outside the group. However, since I factored out a 4, this 4 is actually 16, because I'm taking this 4 and saying 4 times 4 gives me 16. And so then I can go ahead and simplify this down. In this situation, we get a negative 81. And then I would continue with algebraically solving. So adding 81 on both sides, taking the square root, and I would get the roots, or v equals negative 2 plus or minus 9, which is a negative 11 and a positive 7.